Okay, so next question, final question, 68. Draw the most stable form of glucose by putting the OH groups on the appropriate bonds in the chair conformer. So this is actually an extremely simple question. Uh, Again, the main point here is one, being able to orient yourself appropriately to the molecule, and in this case we have a really convenient anchor point, which is going to be this oxygen right here. And all we're going to do is go around this ring. So I'm going to go around this ring in a clockwise kind of fashion, so I'm looking down on it, I'm going to go clockwise. And so this is the first thing that we need to do. So I'm going to label this oxygen as 1 and this carbon as 2. So if we're going to do the same thing on this kind of chair conformer, you can imagine yourself just like with this one on the left. Again, it looks like it's planar, but it's not. It's actually in a staggered chair conformer. You're going to have your eyeball come down like this, so this would be your eyeball, and you'd be looking down at the molecule like this. So in this case, we're going to go, again, still clockwise around the molecule. So this is going to be number 1, and so this one's going to be number 2. So number 1, number 2, and then 3, 4, 5, and 6. So this will be my number 6, really, right over here. So now all we really have to do, everything is the same in terms of the hydroxyl group. So we have a hydroxyl on 2, 3, 4, 5, and a little bit something different on 6. So we'll just take care of 2, 3, 4, and 5. So the first thing you need to remember is how to draw equatorial and how to draw axial. So might as well just go ahead and draw in all the axials. So again, these two bonds are pointing down, so this axial bond is going to be pointing down, axial bond pointing up, axial bond pointing down, up, down, okay? And so now if the axial bond on 2 is pointing down, the equatorial must be pointing up. So let's do an up equatorial, down equatorial, up equatorial, down equatorial, and up equatorial. Okay? So that'll be all of our bonds that we have. And all we have to do is fill them in. And this point is really, really simple. So we're going to start on 2 and just start adding in hydroxyl groups. So the question is, which position is going to be the major position for the hydroxyl, equatorial or axial? And this is still extremely simple. It's just going back to the idea that equatorial positions are going to be way more stable energetically than axial positions. So what we're going to do is we're just going to put all of these hydroxyl groups on the equatorial position. So equatorial here, here for number 3. So we're taking care of 2, taking care of 3. Next up is 4. Just going to put that in the equatorial position for 4. Same thing for 5. We're going to do that with 5. Put an OH there. And now the only thing that's different for carbon 6 is that we have a methylene group or a CH2 group. So again, remember they have two hydrogens coming off of this guy. And so we have CH2 followed by the hydroxyl. So in this case, if we drew the hydroxyl like this would be incorrect because what this is notating is that there isn't any carbon between carbon 6 and the hydroxyl. So we can't do that. So get rid of that. So what we have to do is first add the CH2 and then add our hydroxyl. Okay, so there's our CH2, there's our hydroxyl. Now, at this point, we have all of these axial positions left over, so we can do two things. We can either put in hydrogen for each one of those, because otherwise, if you just leave it blank like this, it looks like there's a CH2, which isn't the case. So if we want to leave those axials in, all we have to do is add in hydrogen, so just making sure that the reader doesn't think that it's a CH3 group or a methyl group, or we could let those hydrogens remain implicit. So we could either draw them out completely, or we can just get rid of the bonds as well as the hydrogen. So this is another totally legitimate way of drawing glucose. And in my opinion, it looks a little bit prettier. There's not as much going on. It's not as distracting. So that's the answer to that question. So basically, it really does come down to, you know, uh, how we want to orient the molecule. How we want everything to be in an equatorial position because that's going to be the most favored position. So yeah, that's pretty much it. All right, moving on to chapter 3.